everyone, my name is Danilo Li. I'm a PhD student in Trinity working in telecommunications. I am funded by the Frontiers for the Future New Wave project. The title of our work is OTFS without CP in massive MIMO. We'll look into one of the main challenges of 6G systems, which is the time-varying channels. Time-varying channels is caused by the Doppler effect, which appears in many of the envisioned 6G technologies. For example, autonomous vehicles, smart cities, and millimeter waveforms. To combat these LTV channels, a new proposed modulation technique called orthogonal time frequency space (OTFS) has emerged with many benefits. First of all, it's easy to implement, as it can be implemented as a shell over existing 5G technologies, namely of OFDM systems, where a whole OTFS block is transmitted as multiple smaller OFDM blocks. Second, the OTFS puts the data in the delayed Doppler domain. And in the delayed Doppler, the channel is invariant and sparse, which makes channel estimation and channel equalization much simpler. However, I like to point out that the channel is only invariant when a channel within each OFDM block is considered to be invariant. This is possible only because, like I said, the OFDM block is much smaller than the whole OTFS block. This will still lead to small limitations, however, but I'll go into this later. And the third benefit is that recent works have shown that OTFS only needs one sequence of cyclic prefix per block, whereas usually in the OFDM systems you would have to append a CP cyclic prefix over each OFDM block. And CP is a redundant sequence used to avoid channel interference. So it is, the more CP you add, the less efficient is your system. So following this trend, we'll look into ways to completely remove CP. And we'll look into time reversal maximum radiation combining and try to use this technique to make the channel into a perfect one. And by doing so, we also look into the channel variations within each OFDM block to enhance the performance. So what is time reversal technique? So time reversal is a known phenomenon in physics, where essentially you take a sequence here, let's say the channel, and you convolve it with its own flipped and conjugate version. And this will result in the new sequence where the power is all focused in one point. And this is perfect for combining because, let's say if you have infinite antennas, combining all different time-reversed sequences will lead into a perfect impulse. And the perfect impulse would be a perfect channel. Of course, we don't need infinite antennas, and approximate perfect channel can be achieved with, let's say, 100 or even 200 antennas. So this TR-MRC has already been studied in time-invariant channels, and we extend this now to time-varying channels. And an interesting finding from our research is that we show that the time variations within each OFDM block tends to samples of the Bessel function. And with this, it allows us to correct them, which, like I said, removes the limitation of OTFS by correcting the residual Doppler, so that's why we name it residual Doppler correction windowing. And in our simulation results, we show that even when you consider much higher speeds of 2000 km per hour, where without RDC windowing, or proposed RDC windowing, we would have a much worse performance. With RDC windowing, we achieve close to time invariant channel performances. So a huge performance increase. And of course, this is all without any CP in the system, so more efficient as well. So in conclusion, we devised TR-MRC to first of all completely remove CP, making it more efficient, and we also correct the time variations within each OFDM block, which removes one of the limitations of OTFS. And thank you very much for your attention. If you have any questions, please ask me on my email here. Thank you.